Welcome as well, Jason, the people who might be listening online, including at least one colleague, I believe, at Katherine Research Station. So welcome, and hope you find today's talk interesting. It is a story so far. Today I'm talking about work in progress. It's work that I've been leading for about the last 3 years, and out of Katherine Research Station, and it's turning out to be quite exciting, interesting, potentially, you might even say transformative for industry looking forward. So I'm talking about fruit flies, mangoes and market access, the story so far. A slightly more fancy title might be using a systems approach to eliminate post-harvest treatments for fruit fly and mangoes. Or maybe an alternative treatment title would be, wouldn't it be great if we could export mangoes without having to treat them for fruit fly? Now you might still have questions about fruit flies and what treatments I'm talking about. We'll unpack that a little bit as we go. So fruit flies, for those of you who might not know, they're a group of insects, a particular family of flies. I might even say now, we're not talking about those little flies that hover around your fruit bowl, the little brown ones, or people often call them fruit flies. Entomologists usually call those ones vinegar flies. If you think about vinegar, it's a fermented type product, and those little flies hovering around your fruit bowl are chasing fruit that have already started to break down in some way. We're talking about a family of flies that are called, if you like, the true fruit flies. And the difference between them and those other vinegar flies, or one of them, is that the adult females of true fruit flies will lay their eggs in sound fruit. So fruit that's actually quite intact and hasn't started any breakdown process. Those eggs hatch inside the fruit and the larvae develop in them. Obviously that spoils the fruit, but also in some crops like citrus, when that stinging happens, when that egg laying happens in the fruit, you'll also get fruit drops. So you get yield loss, you get losses to industry happening in a number of ways. You might get actual yield loss through fruit dropping, but you also can potentially get spoiled fruit. And costs also happen because, as we'll talk about in a moment, these are also serious market access pests. The fact that the larvae can sit inside fruit that might look otherwise sound, that means they can get transported through our supply chains to other areas that don't have the, certain pest species of fruit flies. So that's another aspect of their biology that creates some pest issues, creates some costs, and it's one of the reasons why a lot of places don't want to get fruit flies. In the Northern Territory here, we've got two main economic species of fruit flies. Pictured, we've got Queensland fruit fly, which is really the #1 fruit fly pest in Australia. It's got a very wide host range, attacks a wide variety of fruit. We also have another species here called B.jarvisi's fruit fly, and it doesn't have as wide a host range, but still does attack a range of crops. There's also a vast number of fruit flies in this family that aren't pests at all, that attack native fruits and maybe only limit their attacking to 1 or 2 species. But obviously we're dealing with the pest species here. So if we're talking about fruit flies, market access and mangoes, just to give a little bit more detail on the market access issues, if you can see this map of Australia and you can see some shading indicating there is the presence of various fruit fly species in Australia. And you can see some shading up in that Darwin area. And we up here, as I said, have Queensland fruit fly. Now, so fruit flies are endemic here. If we're growing a susceptible crop and we want to send them to Brisbane, for example, another region that has fruit flies, we don't have to do anything to those fruit. We might not want to send down infested product from a quality point of view, but from a market access point of view, they've already got the species. We don't need to do special treatments of those fruit or go through special procedures. But if you want to send fruit to, say, for example, Victoria or particularly South Australia, that have specific fruit fly free status, then they expect you to do certain things to the fruit and go through certain procedures if you want to send fruit into those markets. So interstate, even within Australia, there's a lot of requirements on fruit producers in fruit fly areas to comply with. And of course, if you're going outside Australia as well, up or across to New Zealand or wherever, then you've got added requirements as well. What are these extra things that we need to do to the fruit? Well, usually it comes down to the word disinfestation. We're saying that there's a risk in certain fruit that they might have larvae inside them, and so the option is to disinfest. And there's a few different ways that we can do that. A lot of the interstate market access to date has relied on insecticide dips and sprays. So fruit is literally picked off the tree and then given an insecticide treatment, not in the field but in the packing shed. And the insecticides used are ones that usually only just penetrate into the skin layer of the fruit and will kill any eggs or larvae that eggs that have just been laid or very new larvae. And that's meant to provide some level of control. And that's been the mainstay to date of interstate market access in Australia. Other options are chemical treatments via fumigation, so using a chemical in a gas form to kill any larvae that might be in the fruit. There's also the option of using physical treatments, so usually that means hot or cold treatments to kill the larvae. In the case of mangoes, we don't have any cold treatments, though those are used quite widely in citrus and some other commodities. But vapor heat treatment is a word you'll often hear bandied around with the mango industry, so that's using a high level heat temperature for a short period of time to kill and actually kill any larvae or eggs that might potentially be inside a fruit. And the other one is irradiation. We're actually using high energy levels to zap potential larvae that are in fruit. And that's one of the methods that a lot of international markets require. Now that all sounds good. It means that we've got options. If Australia, we're a nation with a range of fruit fly species. Northern Territory, we have a few, and it means that we've got some options to access markets and recognised options to access markets. But there are some problems with disinfestation. One of these, that a lot of these treatments are expensive, even if individually they're not. Some of those chemical treatments that we use in interstate market access aren't. They're relatively cheap. But there are always hidden costs with these things as well. It's the cost of maintaining all the records, maintaining all the equipment required to do that. These are all costs for businesses. The other thing, you can imagine treating a mango that's just been picked with heat. It's not actually the best thing for mango fruit quality. A lot of the disinfestation treatments have impacts on fruit quality. Irradiation does that. It's accepted that if you irradiate mangoes, you're going to get a certain amount of losses. A certain amount of the fruit that's treated won't be fit for sale. If you're in New Zealand and you get irradiated mangoes from Australia, they're still okay on the inside, but they're blotchy in appearance on the outside. They don't mind because they can't get them any other way, but the fact is that most post-harvest treatments have some kind of impact on fruit quality. The other thing for our interstate market access, and this was one of the key issues when this work started out, that the chemical treatments used, two chemicals in particular called dimethoate and phenthionine, both old-style chemicals, have been under review by not just national regulators within Australia, but internationally as well. Europe, as with a lot of things, won't allow them at all. Australia, late last year, announced that those chemicals were no longer allowed to be used for fruit with edible peels. So things like tomatoes, stone fruit, that had previously relied heavily on the use of those two chemicals to access markets within Australia, suddenly lost access to those products. Mangoes retained them because I don't know of anyone who eats a mango skin. It was classified as a fruit with an inedible peel. But the point is that the continued availability of those products into the longer term is pretty shaky from a regulatory point of view. And that's all about humans' safety and trying to reduce overall dietary intake of these products below safe levels. In fact, using some of those chemicals can restrict your access to certain markets. So I mentioned if you treat your product in Australia with dimethoate or phenthionine for interstate market access, you actually can't send your fruit up. You've got no option to send those fruit to an overseas market like Europe, for example. And there have been instances where businesses have cleaned out their spray line, cleaned out their packing line, and done all they could to eliminate send untreated fruit to European markets. And there's been a slight trace picked up, and those shipments have had to be suspended effectively. It costs those businesses tens of thousands of dollars when that happens. So, in fact, using some of these disinfestation methods can restrict our market access. There's the whole OH&S thing about using chemicals in sheds. Can we get rid of them? And we think about our consumer, and is there the potential to supply not just high quality fruit fly free fruit, but actually untreated fruit as well to them? And that's the big question we have with mangoes. Not so much with a lot of other really susceptible crops like stone fruit, but certainly with mangoes, we've got a big question: is all this disinfestation even necessary? Because there is possibly an advantage that mangoes have over a lot of other commodities. Here in this picture, I've got a picture of one of our local fruit flies, the Jarvis fruit fly, sitting on a nice ripe mango. And we know, entomologists and other people, home gardeners, have certainly found that fruit flies will attack, lay their eggs, and you will find larvae in nice ripe mangoes. And that's usually how we think of mangoes as consumers, as nice ripe mangoes. You know, like in that box there. But the reality is, if you don't know, that when mangoes are picked at a commercial level, you can see those mangoes in that photo, they're green. And they're not soft and they're not ripe, they're hard and they're green. They're picked at a stage where they're mature, that is, they will ripen to the mangoes that we enjoy to eat. But they're quite a different proposition potentially for a fruit fly to lay her eggs inside a hard green mango at the stage of commercial harvest versus one that's been left a bit too long on the tree there, that one that's overripe. And so one of the key questions we've been looking at this work is to resolve some issues around the host status of hard mature mangoes at commercial harvest. Because if it's true that hard green mangoes aren't infested or are infested to only a very slight degree, then a lot of this disinfestation that we do for mangoes is potentially unwarranted. The other potential advantage we have, and particularly in a place like the Northern Territory, is that here's an aerial shot of one of our mango farms where we're working at down in Katherine. Can you see all the other farms around it? And the reality is, no, there's not. A lot of pest issues and a lot of fruit fly issues come because you've got multiple crops, multiple commodities being grown in close proximity to each other. You've got a continuous cycle of hosts that insect pest populations can breed up in. And yet the reality of a lot of our production, and in particular in the Katherine region, is we've got isolated farms surrounded by bushland and potentially limited host availability, although one of our flies does have a lot of native hosts in the bush. But that's been a key dynamic of our area. And so one of the things we've been wanting to resolve as well is what are the baseline populations of pest fruit fly species in key NT production areas. And if you didn't know, the NT actually produces about 50% of the national mango crop, and about half of that comes from Katherine. So over the last 3 years, we've been working with the major commercial producers down in Katherine. This work relates directly to somewhere between 20 and 25% of national mango production is what we've been working with. So it's significant in a national context as well. In a slightly more wordy form, what have we been trying to aim with our Katherine project? What have been our aims for the last few years? And it's to maintain and expand market access for mangoes, initially looking at the Katherine region through the pursuit of alternatives to chemical disinfestation for fruit flies. That whole issue of chemical availability for interstate market access was the key driver initially. And our key question is, could a systems approach, and systems really means not relying on one thing, a single treatment, but on putting a few different things, different aspects together to achieve the same or a better result. Could a systems approach based on farm-wide suppression of pest fruit flies in the Katherine region, if required, and adherence to fruit standards at picking grading, so that's not putting the ripe fruit in and making sure we only pack hard green fruit, have the potential to replace the need for post-harvest disinfestation. And the goal is not just to produce a scientific paper at the end of the day or a few, but it's actually aimed squarely at that market access issue to see if we can get up some new market access protocols that would be accepting to trading partners, both interstate and internationally. And so this project's about developing the evidence base for that. Our research activities probably split into mainly 2 categories, but I've got a third one there as well. We spend a lot of time assessing fruit fly risk in untreated fruit. And obviously from what I've said, we're really looking at untreated fruit. Can we send fruit without having to do any post-harvest disinfestation at all? And so there's a photo of my offside and my technical officer at Katherine Research Station, Mike Carl, and this is what we have to do, collect fruit before it goes into the packing shed and gets treated to assess the background fruit fly risk. And you can see again that most of those mangoes there are nice, hard and green. We've got, we also do a lot of work with looking at fruit fly populations, and again, that's just another photo of one of the production areas we're working with. We work with both old orchards and new established developing orchards. One of the ways we monitor fruit flies is by using these traps there, that device with the yellow lid on it. One of the interesting things about fruit flies is that Their biology allows us to monitor at least the males of them. We have some pheromones now, and one of the new things about this study is we've now got the ability to monitor Jarvis fruit fly. Up until 2 or 3 years ago, a few years ago, there wasn't a lure for that species, and that's now been developed in Queensland. So this is one of the most comprehensive, assessments of Jarvis fruit fly. Well, really, it's the first major assessment of Jarvis fruit fly activity around mango orchards in our production area, and that's in any production area in Australia. So we're sampling both in orchard areas and surrounding bushland areas, and there's that photo again. Those red dots indicate trap sites both in bushland and in the main orchards. And here's another site that we're working with, two very large orchards as well. Again, you can see we're looking at a range of sites. That's the Katherine River running down there on the right-hand side, and sites both within the orchard and on the edge and in the native vegetation. I won't dwell too much on results, but this is the results from our Jarvisi monitoring over the 4 main production zones that we work within the Katherine region area. And the main thing to look at is the numbers on those yellow bars roughly indicate the mango season, when mangoes are available and being picked. And the peaks, the lines represent 4 different areas. And what you can see is we have big peaks. Look across to the left-hand side, and you'll see some fairly large numbers, 300 to 400 flies per trap per day. That's the way we measure flies. And where would you like to be? Well, a lot of places, if they were looking to get an area of low pest prevalence, which is an internationally recognised level standard, you'd prefer to be more down 1 or 2 flies per trap per day. So we're well above that with this Jarvisi. But just hold that thought. We might have a lot of flies, but doesn't mean we have a lot of fruit fly risk. But just to look at our other species, you'll see the numbers are quite different there. Queensland fruit fly, Bactrocera triani, which is usually regarded as the more serious, it's the one that really all our regulations are based around in Australia. The numbers are significantly lower. Our worst zone there has a peak of about 70 flies per trap per day. And if you can see the purple line at the bottom there at Mataranka, extremely low. We actually are at that 1 to 2 flies per trap per day. That's been really interesting to see those differences between even just different areas within the Katherine area. And in fact, Mataranka would say on that basis, not with Jarvisi, but with Q fly, Queensland fruit fly, actually already qualifies for area of low pest prevalence and internationally recommended level based on for Queensland fruit fly alone. And you put them together on the same scale, and that's the sort of picture you get, just results from 2 seasons. Big peaks of Jarvisi tending to happen late in the season, and Q fly beetling around at those lower numbers. And certainly the Q fly numbers are lower than other districts, comparable horticultural districts in Queensland, etc. So they really do. We do have an advantage with Q fly. The big peaks of Jarvisi are largely to do with its other main and preferred host, which is a native plant called cockapple, Planchonia correa, and it's quite abundant in that savanna scrub around Katherine, and it's abundant up here in Darwin as well. And it's the major host that drives the biology and the population outbreaks of Jarvisi, which also gives us some possibilities to manage it down the track as well. So we have, so it's been quite. We're really now just at the point where we're starting to see what can we do with these populations. We now have baseline abundance data for both pest fruit fly species in the Katherine Mataranka region, and importantly, and this was the reason why we've spent 3 years in a way of just seeing what's there, this will allow us to demonstrate the impact of interventions to suppress fruit fly populations in and around mango orchards as part of systems approach for market access. So we wanted to see if we had to do anything to the fruit fly populations, but now we know that if we do, we can actually measure the impact of those interventions. So as I said, the other part of it is yes, looking at fruit fly risk from what flies are around to now looking at what's actually turning up in the fruit. And you might expect that with all those Jarvisi flies turning up, we do have a potential for a lot of flies to turn up in the fruit. To date, we've assessed over 60,000 fruit. What we tend to do is collect untreated fruit at the shed or at harvest in the field. We do some measurements on various fruit quality parameters, and we then hold them for a little period. That gives the time, if there were any larvae in there, to grow to a size where they're easier to detect. And we make sure that we actually are picking up infested fruit. And it fairly much replicates what happens in the commercial supply chain. So what we see after holding it for 12 to 14 days is what the shop owner or the customer would see by the time they get the fruit ready for consumption. So here's some pictures of that. We go and collect these fruit. As I said, mostly hard and green. We've, and particularly started this last year, we get some commercially trained staff to do commercial grading, so we're assessing all our fruit against commercial standards of quality. And then we do some additional grading back at the lab as well, where we actually squeeze the mangoes and do things like that to rate them as hard, rubbery, soft, firm, soft, according to some industry standards. We always on a subsample, and last year we did not just subsampling, a lot of cutting up mangoes and grating them and doing dry matters and sugar tests and all these things to see if there were certain quality parameters that coincided with higher fruit fly risk in those fruit. And then after the 12 to 14 days, and you can see those bright yellow mangoes there, and then just the right stage to eat as well, we cut them up and look for fruit flies, and we found very few. Just to give you an idea, this is a graph, and when a mango comes in, it starts off green, obviously gets more yellow, and those more intensely yellow areas indicate when we have a higher percentage of ripe and more susceptible fruit in our samples. So in this particular trial last year, we looked at about 1,600 fruit, and they started off all fairly green, but over the season we let them hang on the tree. This wasn't a commercial sample as such. We let them hang on the tree into periods of higher fruit fly risk. We had more ripe fruit appearing. You would think, are we going to pick up something? If we're going to pick up any fruit flies, we're going to get them, particularly on that last sample, 19th of the 11th, and we didn't find anything. And that's pretty standard for what we get. Even when you've got susceptible fruit, ripe fruit, we know ripe fruit are attractive to fruit flies. Even when we've got attractive fruit, we've got them at, around 20% or more, perhaps 50% or more in the sample. We're still just not getting them. And you can put those two things together then to say, well, so this is from that same site. You can say those yellow bars represent the mango season. You can say, well, we did have fruit fly numbers building during that time. Yes, by the end, they were even quite high, up around 100, 150 flies per trap per day. And even with susceptible mangoes, we weren't getting any stung. Now, we did have some detection, and this is just another little graph just showing that when we look at fallen fruit on the left-hand side, which are the ripest yellow fruit, we do find infested fruit, but generally speaking, when you go to the commercial fruit, and we looked at many more commercial fruit than fallen fruit, we only had one detection from that whole farm. And what we do find is that most of those detections relate to off-spec fruit, so fruit that wouldn't have been packed under a normal system. The good thing about this number is it's just a summary of our results from one variety from last year. We looked at, with this variety, bottom right-hand corner, nearly 8,000 fruit. Underneath that, there were 3 infested, but lots of zeros. If you look at that other column there, most of them were, they were pretty much all in the reject category, although there was one, if you can see in that C2 column, 1 detected. So that's one of the wobbles in the data that we need to be very aware of. That's a little bit of risk. We went to another variety, and last year we looked at about 9,000 of those fruit. We had 7 infested, but if you look through that, they were all in the reject category. So that's the sort of results. They're very encouraging. What does an infested fruit look like? Often they look like this. They've got some other blemish that has predisposed them to attack. And if you open that one up, you can see the larvae inside them. That was some other unrelated insect damage that occurred there. Again, here was another fruit. You can see the larvae in there, but you can also see that dirty big scar. And that's the sort of fruit that often are infested. And here's some coming across the sampling line, and you can see most of those fruit are nice green, but you can see, at this stage late in the season, there's 1 or 2 more bright yellow ones. They're the ones you'd be trying to eliminate from packing. That's where most of the risk sits. Just going to skip over very briefly. So that's where we're at. We've got a very low risk, baseline risk sitting there in the fruit. We do have some high fruit fly numbers, and just every now and then we do find a hard fruit that's attacked, but the numbers we're talking are probably 5 out of 80,000 fruit that we've looked at. And that's across a range of varieties, and some of that focused more on one variety than the other. So it's not watertight, but it's very encouraging. And that's without us really doing anything to manage this situation. So one of the exciting things, I'll just skip over this quickly, that we're going to do this year is to look at population suppression at one commercial site. We're doing it at a very large commercial scale, and we're doing it focused on DPIF because pretty much all the detections in our studies have been that species, and all the detections in the supply chain recently, which haven't been very few, but have been that species. Infestation levels are low, but what can we do to reduce this even further? There's probably two things. One, we can try this thing called the male annihilation technique. So if you can kill the males, basically you can have enough of them, you can limit breeding. And the fact that they breed mainly on one host tree gives you some options to control that. So it fits into a broader scheme. But here's just a pictorial picture of Jarvisi suppression. So you can put out these little lures with the attractant, the lure that we use in the traps, but you put them out at really high density. They send out a plume of chemical effectively, and you put them as far out from your orchard as you can. There's a zone around them, where basically you're suppressing mating if all this works. What happens is the lure attracts them in, and there's a small amount of insecticide at the lure, and the males will feed on that and die and not mate. So you're trying to create this area where mating isn't happen, and if you can get it out far enough away from your orchard area, then yes, mating will be happening quite distant. But you're trying to reduce the chances of a female mated fly coming into your orchard. And let's imagine you've got some host trees growing around, ideal breeding sites outside your orchard for this thing. Well, you've got the potential to, if you can suppress breeding more around that, or even manage those trees directly, then you further reduce the risk of a fly coming, from close in into the middle of the orchard. And so it's only those distant ones and long flies that have the risk of coming in. So when we bring it all together, and I'm going to finish here, when we bring it all together, we see that we've got the possibility of looking at areas of low prevalence, areas where some of our species particularly are quite low, but we have that Jarvisi that's a bit high. We have the mangoes that don't like that, generally speaking, aren't attacked, and our data is supporting that, but showing there is still a little bit of risk there. So what you do then is you do inspection, grading, culling and packing processes in the shed. And if that's not quite good enough, then you do a little bit of suppression of the flies over the top of that. And hopefully that is enough to provide and give your customers an assurance that they're receiving not only fruit fly-free mangoes, but fruit fly-free untreated mangoes with all those costs and issues around disinfestation. And one of the areas we're really excited about is Mataranka, because when you look at the Queensland fruit fly trap catches already low, as I mentioned before, already sitting on an area of low pest prevalence. There is this challenge with the Jarvisi that reaches high numbers late season, but if that male annihilation technique works, so I can show you, then we have the potential to really drop that. And there's also some other tools we can use as well. So we think that it's looking very promising that we can have suppressed fruit fly populations at this site due to naturally low Queensland fruit fly, active suppression of the other species. And then we've got further reduced risk due to the natural reluctance of female fruit flies to lay in hard mature mangoes. That's the stage when they're commercially picked. And we also have that other option of looking at and that's why we do all this quality, looking for it to implement harvest grading, packing and inspection processes that exclude at-risk fruit. And so it ends up being that we're not just thinking about fruit flies, and we're not just thinking about mangoes that we have to treat, we end up thinking about the whole system. And basically, we try to make sure that our flies are low if we need them to be low, and that any infested fruit end up in that reject bin in the bottom corner. And our results today indicate that there's good prospects for that occurring. Thank you.